book. What if you could paint a stunning landscape, compose a hit song, or recreate a childhood memory, all without seeing the original, just from scraps and sketches? What if AI could do the same? Today, we'll peel back the curtain on a scientific breakthrough that lets machines imagine the impossible, drawing the real world from mere hints, masks, and missing pieces. Topic Introduction. For decades, artificial intelligence required a precise diet, complete data, labels, and meticulous detail. Want to teach an AI to colorize old films? You need thousands of labeled color frames. Want to generate a human face? You need millions of perfect portraits. But in the real world, data is full of holes, obscured, incomplete, shredded by noise, or missing altogether. So, how does AI cope? Enter a breakthrough in unsupervised learning, a system that lets machines rebuild, restore, and even create data by learning the essence of what makes reality tick, based solely on shattered clues. The core concept we're exploring is known in the research community as diffusion models. But today, let's focus on the astonishing ability this technique gives AI, generating, repairing, and visualizing complex things, even when most of the puzzle pieces are missing. Core concept explained. Here's how it works. Imagine you hand an AI a photo, but you ask it to deliberately erase details, add noise, blur, scribble. You then challenge it, uncover what's underneath. Reconstruct the original. The model learns, over many examples, the subtle rules of how faces, landscapes, or objects are formed. Backed by this internal blueprint, it learns to run the process in reverse, from total chaos to a clean, plausible reconstruction. Like a master restorer who can rebuild a Renaissance painting from a water-damaged scrap, this AI can fill in gaps, denoise corrupted signals, and even invent segments it's never truly seen. But here's the kicker: the AI doesn't just memorize. It learns a generative process, an understanding of what makes a scene believable. When asked for something new, it can create an original work, one brushstroke at a time, starting from random noise and gradually assembling order. Technically, these models simulate the gradual transformation of chaos into clarity. They start with complete noise, and at each step, predict what the less noisy version should look like. By chaining together thousands of these small, smart guesses, the AI can morph random static into hyper-realistic art, vivid audio, or seamless video. Use cases. This revolutionary process doesn't just power cutting-edge art generators. It's transforming industries. Restoring history *, bringing clarity to old, degraded photos and recordings, filling in missing voices or faces. Medical imaging *, reconstructing clean MRI scans from noisy or incomplete data, making diagnosis faster and safer. Content generation *, powering modern creative tools, think AI-powered games and film production tools that invent entirely new visuals or worlds on demand. Hypothetical discovery *, simulating molecules or proteins that have never been observed, accelerating drug research and materials science. Importance. Imagine the future, AI that can reason beyond its training set, generating the unseen, the unlabeled, the never complete. This generative magic opens up science, art, and technology to anyone, no perfect data needed. Artists, doctors, scientists, even kids, can interact with AI as a creative partner, a collaborator that dreams, restores, and invents side by side with us. Q&A. Q, doesn't this just create fakes? How do we trust what's generated? A, while it's true that generation can create synthetic versions, the technology can also estimate uncertainty. Responsible use involves labeling generated data and designing systems where AI supports, rather than replaces, expert judgment. Q, is this approach data hungry? A, initially, yes, since the model learns the laws of reality from large amounts of noisy examples. But, once trained, it can operate with little or even no direct data for a specific task, using what it knows about the world. Q, why is this different from older methods like GANs? A, unlike adversarial approaches, one AI trying to fool another, this method simulates the gradual evolution from randomness to realism, which can be more stable and controllable, especially for high-resolution or complex data. Closing. This breakthrough doesn't just let AI repair, restore, or even dream. It democratizes creation, making the impossible accessible to everyone. No perfect data, no elite team, just the spark of possibility.